Now let's just take a look at the Resource Modeling Solutions platform, RMSP. RMSP is also a Python package, and the RMSP also leverages a lot of these packages that we talked about, NumPy, Pandas, Matplotlib, and I'm going to be showing that. So you might recall that we already loaded RMSP, we already did import RMSP before, and we used that just to locate one of the RMSP example data files, the CSV, that we loaded with pandas read CSV. So at this point, what we have is a raw pandas data frame. So if I look at the type of this object is a pandas data frame. And when we look inside this data frame, we see information like drill hole ID, we see coordinates. So we know this represents composites, this represents drilling data, which are basically points in space. So RMSP implements a particular specialized data frame for this type of data, which is called RMSP.PointData. So RMSP.PointData, if I want to initialize a point data, I need to provide a data frame, and this is just the raw pandas data frame. And we need to specify a few more information. So if I press Shift Tab, there is extensive documentation of this function. With RMSP, we try to be very comprehensive in terms of documentation, so you find all the information you need when you check and introspect into the function. So for point data in particular, the information that we can specify are coordinates, drill hole IDs, and the intervals. So let's just do that. So we know that drill hole ID is the column DHID. We know that the coordinate X is column X, coordinate Y is column Y, coordinate Z is column Z. So this is the minimum requirement for this point data. Actually, drill hole ID is extra. The minimum required for point data is just the coordinates. We can also specify the intervals from and to. So if I type from, you will notice that this turns green. And that's because from is a reserved word for Python. So it's not good practice to use this as other variables. So the way we implemented this in RMSP is that we added a I in front of it. So we use I from, and then the column for from is just from. And similarly, just for consistency, we do I2, and then the column for to is 2. So this will initialize a RMSP point data, which we can assign to this comps that stands for composites, and we can take a look at the data. It will look exactly the same. The only difference is that this object now contains a lot more methods that are oriented towards geostatistics, and at the same time it also knows a few information. So it knows where to find the coordinates, it knows where to find the drill hole ID, it knows where to find the interval information. So now we can start looking into some of the functions and methods that we find inside some of these objects. Just keep in mind that point data is a data frame, but it is a specialized data frame with more functionality. And there are other objects within RMSP that are also data frames, but more specialized data frames, such as grid data for holding grids and subgrid data for holding subgrids. So yeah, we do use pandas data frame extensively within RMSP. So let's create a scatter plot again, but this time using the point data to see how it looks like. So within RMSP the point data, we can do .scat plot, and the two arguments it takes are the variables that we are calculating the scatter plot for. So that's going to be copper and element A. So if I run this function, you will see that it generates this plot. It is already labeled. So X label is copper, Y label is element A, and then it adds this little statistics at the top, and also the scatter plots kind of colored by the density. So all these things are performed internal to this function. So remember that when we created a scatter plot with just raw matplotlib, every single detail of the plot required me to add a line of code. So because these objects within RMSP are specialized for geostatistics, everything that we usually do is typically already done by the function, so that the user doesn't need to do that over and over again. So let's take a look at one of the arguments here, stats. So here, this is kind of the minimum statistics that we see, but we can see maybe all statistics. Let's see all the statistics. So now we see more things. We see number of data, we see the covariance, we see the correlation, we see the rank correlation as well. So those are common things that we do within geostatistics. Let's take a look at other things we can do. So for instance, recall when we created histograms with using the raw pandas data frame functions. So let's see how that looks like with RMSP. So fig axis equals plt subplots, and I want 1 row, 2 columns, and I want to change the fig size to 12 by 5. And that will create the 2 axes that we now want to populate. So his plots within RMSP is comps.histplot, and then the only thing we need to specify is the variable that we'll want to calculate this the histogram for. And of course we need to specify that we want to add this to the first axis. So first axis is going to be histogram of copper, and the second axis is going to be the histogram of element A. Let's change a few things here. Let's add a grid lines, and also let's show some minimal statistics for element A. So if I run this now, it generates the histogram. So with just a few lines of code, it is already labeled by copper. The y-axis is labeled properly. The axis limits are reasonable depending on the data limits. And we also have a lot of statistics information to this plot. Number of data, mean, standard deviation, coefficient of variation, minimum, P10, P50, P90, maximum. So those are all useful statistics for our context. Of course, if you don't want to see all of that, you can specify minimal like I did in here. And in that case, it just shows the number of data, the mean, and the standard deviation. So as I mentioned, RMSP has been designed for the context of geostatistics. So one thing that we do is outlier analysis, and one of the plots we typically look at for that analysis is probability plot. So to get a probability plot within RMSP, we have this prob plot, which only takes the variable. So if I run this cell, it generates this probability plot. We can see the distribution. We can see that's properly labeled. Copper on the x-axis, probability on the y-axis, and we can see these colors. These colors, they are defined for the Tuckey fences. So basically those are calculated based on the interquartile range and a constant applied to that. And a smaller constant is used to define an outlier, and larger constant is used to define the far out. It's not always useful. The Tuckey fences, we can turn that off, but sometimes it is, so we have that. But yeah, this probability plot would be something that we would typically have on our exploratory data analysis. So that's implemented within RMSP. We know that this data set is a point data. We have created it as such. And with PointData, which is a type of spatial object with coordinates, we can create sections and visualizations of the spatial coordinates. So for instance, I can do comps.section plot and copper, and this will create a section plot, in this case a plan view section of copper. It's colored by copper. We can see the color bar. We can see that it's being labeled. The spatial unit is provided. So very easy to generate a section plot within RMSP. We can look at other orientations by specifying the orient function. So we can see at X, Y, Z cross sections. We can see XZ cross sections and back to plan view. So very easy to define section plots. All of this again is going to be covered in more details on the Introduction to RMSP series. Here we are just taking a quick look at some of the RMSP functionality.